pants are showing today. No? Let's get started. What are rare earths? Why are they so special? Do we have them in Brazil? But I prepared a very complete answer. This topic is really good. I'll give you a spoiler already. Yes, we do have them in Brazil, and they are super important. But stick around until the end, because there are some really good questions in this video that just keep coming. A question from Douglas, who is a member of the channel. Iberê, what does the bank treasurer have to do with scissors? When I was younger, I used to think that, I don't know, maybe he cut up documents and papers. But I know that's not it. Yeah, that's not it. A treasurer isn't someone who works with scissors. It's someone who deals with the treasure. So if you go, I don't know, to a samba school, or to the bank, the treasurer is the person who actually handles the money. Who opens the safe? Who makes the payments? Who's actually dealing with the treasure, with the money? But if I did this answer here, it would be kind of just memorizing, right? And what about Tesoura? Is it a female treasure? Tesoura, the wife of Tesouro. Tesoura comes from the Latin tonsorius, which means to cut or to shear. If you look at old scissors, you'll see they were one piece with two blades that close together, which even today is a tool used to shear sheep. Tesouro also comes from Latin, but it comes from tesauros, which actually means treasure in this case. So, tesoura and tesouro both come from Latin, but they have completely different origins. These two words just happen to sound similar. Treasurer isn't related to scissors. How do plants grow on islands? I don't get it. That's a good question, right? Because after all, if the island is way out there in the middle of nowhere in the Pacific Ocean, how did a seed get there like magic and give rise to a tree, some grass or whatever? Basically, there are three ways seeds can spread, right? Nature has three mechanisms to spread seeds. The first is the wind. The wind carries the seed away, and a lot of seeds are kind of adapted for the wind, right? Over a long time. The seeds that flew better spread more and became predominant. We have several small seeds with wings that look like parachutes and can be carried. This type of seed dispersal is called anemochory. This anemo reminds us of wind, like the anemometer used to measure wind speed. Another way seeds spread, possibly farther than by wind, is through birds. The animals eat the seeds and then fly far away and poop somewhere else. The seed manages to survive the whole journey inside the bird, and that way the bird ends up planting the seed somewhere else. Or the seed can even get stuck on the bird, on its wing, on its foot, somewhere, and travel along with it. In biology, this is called zoochory, with zoo meaning animal. A third method is seeds being carried by water. Picture a coconut tree by the sea with a coconut falling into the water. There are currents in the sea, like rivers inside the sea. The water flows in one direction and ends up going very far. A coconut can cross the Atlantic Ocean, for example, and grow on the other side. And then the name of this dispersal is hydrochory. Hydro, you already figured out that it means water, right? If I own a store in Brazil, can I price items in dollars? No, okay. According to the Consumer Defense Code, Article 52, the price of the product or service has to be in the national currency. I saw on some lawyers' websites that there's an exception, which is when you're buying a ticket, buying a travel package, things that are negotiated outside Brazil, the price can be in dollars. But in the end, when it's time to close the package, the information in reais has to be clearly stated. But then maybe you'll ask me, hey, we see prices in dollars everywhere these days. Yes, because the world has changed. For example, we can buy items from websites outside Brazil in other countries and currencies. Subscribe to a foreign streaming service or book a hotel directly from your phone. Over there in Europe, you kind of don't even think that you're dealing with different currencies. It almost feels like something out of a sci-fi movie. Imagine pointing a translator at someone so they speak their language and you understand in yours, like Google Translate for money. You speak in reais, but the system processes in euros, dollars, and yen. How do I overcome shyness? I'm 25 years old and I still have trouble interacting socially. I didn't look anything up to answer this question. I don't even know where to find this information. And I get kind of wary about the things that show up on the internet, a bunch of weird stuff and all. I'll tell you what happened. I was a very shy kid, really closed off. When there was a school presentation, I hated going up on stage. There was a play in 5th grade and I worked really hard so I could be the director of the play and not have to go on stage at all because I didn't want to be seen. but throughout my life, I was kind of forced to start showing up. In fact, if you watch the first videos of Manual do Mundo, you'll see that there are several videos where only my hands appear, because I didn't want to be seen. It was just my hands there. I just wanted to have a voice in the background and didn't want to show my face in the video. And what made a big difference was putting myself in situations where I was forced to deal with my shyness. I had to overcome my shyness because I was already committed and had no choice. For example, accepting a television invitation. I once went on Google's show and presented 10 experiments. I couldn't sleep at night. I felt sick. I would get there shaking with nerves. And there was one experience in my life that put an end to all of that. Nowadays, I have zero shame about appearing on television or getting up on stage because of that experience. In 2014, we recorded a television series called Extraordinary Experiments. And it was a series based on me, based on Manual do Mundo. I was the protagonist of the series, and it was a series of... It was fiction, not reality. So, I had to memorize the script and I had to act, right? I had to pretend what was happening. And I'm not an actor, I had no experience as an actor. I did some actor training, right? It's like a preparatory course for the series, focused on that series, so you can play the character. A television series is unrelated to the filming we're doing at Manual do Mundo. Today, in this room, I'm Johnson operating the camera and Augusto, our guest, is watching the recording. No, during the series recording, I counted. There were 40 people behind the camera. There's the director, script supervisor, camera 1, camera 2. Each camera has an assistant. There's a director of photography, 3 people for makeup, 1 for costumes, electrician, grip, art director, props producer. The television network supervisor is present, along with other actors who aren't included in the 40 I'm counting. So, the night before the first recording, I simply didn't sleep. I didn't sleep. I spent the whole night wide awake, nervous, afraid of what it would be like to put myself out there in front of 40 people at the same time. And when you see those bloopers on television, it all seems funny. But in practice, in real life, it's not. When there's a recording and you mess up, you're holding up the whole crew. You're delaying the schedule for the entire series. So maybe some mistakes can even be funny. People laugh. But after you mess up the same line 10 times, no one can take it. Everyone gives you dirty looks. When I got to the set, you know, the filming environment, my voice just wouldn't come out. If you don't sleep at night, your voice will be weak and bad the next day. The audio guy, oh, there's the audio team, which I forgot to mention in this whole list. There were 3 people on the audio team. They said, Iberê, project your voice, speak up. I can't. My voice just won't come out. I didn't sleep the first night. Then I slept 2 hours, 3 hours, and 4 hours on the next 3 nights. But it was 4 months recording. There came a time when either I lost my shyness about speaking, about acting in front of other people, or I was going to die, because there was nothing else I could do there. So, by the end of the series, I was no longer shy about being in front of other people. I wasn't embarrassed to be in front of the camera. I wasn't embarrassed to speak publicly because I had created and gone through this situation myself. So, if I had a tip to give you, it's to put yourself in situations where you'll feel embarrassed, where you'll have a hard time dealing with things. I don't know. So, go do theater, join a non-governmental organization, do some volunteer work. Eventually, you'll need to introduce yourself, request something, or make a sale. My watch shouldn't have gone off just now. But anyway, where you have to put yourself in an embarrassing situation that you can't escape from. You can't leave, and you'll be forced to get over your embarrassment at that moment. The planet is round, right? I'll pause here. Earth is round, not just rounded. We have some little imperfections in this sphere. For example, the equator. If we measure the equator, it's a bit larger. Then if we make the same measurement passing through the poles, measuring the meridians, that means the planet Earth is a little bit flattened. If you look, there are some imperfections on the planet. The ocean, for example, isn't smooth. Gravity causes some places to be slightly higher or lower. But all this is tiny compared to the planet's total size. If we take a spaceship and look at planet Earth from afar, it's perfectly spherical. You can see that from a distance, okay? And not up close either. So for all intents and purposes, we can call planet Earth a sphere. There's no problem with that, okay? But let's go on. If the planet is round, why doesn't water fall off? Let's check from the bench. What a lot of people have in mind is that planet Earth is like this tennis ball. And if you pour water on the tennis ball, look, the water runs off. The water doesn't stay on the tennis ball. So, theoretically, in space, shouldn't the water on planet Earth run off, fall somewhere? But then I ask, fall where? Fall to what ground? on the waterfalls of the little ball because gravity is pulling it. Because there's a big planet underneath the ball that's pulling this water. Oozing. And it pulls toward the center of the Earth. We say it's in the radial direction, always pulling toward the center. So when we think about the planet, if you have water around the planet, this water is being pulled toward the center of the planet, not downwards. So yes, it falls toward the center of the planet. Eventually it stops and forms a reservoir, sea or lake. Another thing that raises a bit of a red flag for me in this question is that we imagine that planet Earth is full of water, but that's not really the case. It's a very thin layer of water that we have around our planet. The ocean's deepest spots reach about 11 kilometers, Kabilu. So, if this were planet Earth, the layer of water we would have on top would be about as thick as a strand of hair. An absurdly thin layer of water, a layer of water that's even thinner than the water left on top of this little ball when I got it wet. In space, how does a person know if they're right side up or upside down without the gravity? I won't get into that because it's a long story. It's not exactly that there's no gravity. It's that you don't feel gravity if you're in orbit around planet Earth, for example, Vida. So inside the International Space Station, which is the main place where astronauts stay, they don't feel the sensation of gravity. They float around there. And in that situation, there's simply no such thing as up or down. On the International Space Station, rooms have no floor or ceiling. Everything is a wall, so they store the tools, research instruments, and everything else everywhere. If you look there, there's Velcro everywhere to attach things to the wall. Even because in this situation, if you let go of a hammer, for example, it will float there and hit someone's head. So, this idea of up and down only really makes sense if you're really feeling gravity like we do here on the surface of planet Earth. Jensen is asking if, when someone is there on the International Space Station, looking out the window and seeing planet Earth, if they're kind of upside down in relation to Earth, won't they feel dizzy? Well, unfortunately, I've never been there, so I can't give a personal account of what must happen. But I imagine that yes, it must give a really strange feeling. And the people who go to the station say that in the first days they feel fine, then bad, they vomit and everything else, because this thing of not knowing what's up or down anymore makes your body a little crazy in the first days, but then it goes away. Why is it that when it's hot and windy, we feel refreshed even though it's the same air, just moving faster? The question makes sense, right? Why does the fan cool you down if it's just blowing air at the same temperature that's already around you onto you? If it's hot, for example, shouldn't you feel even hotter since it's more hot air coming at you? There are at least 3 things that make the fan cool you down, yes. The first is that when I'm standing still here, a layer of hot air forms around me because my skin heats up the air. This layer slowly rises because hot air rises, but still, if we could look with a camera, you would see around me a kind of hot air mist, which slowly rises. This air helps regulate my body temperature. When the wind blows, it takes away this layer of hot air. And this air, it's over 30 degrees right here, right? My skin is slightly cooler than my internal body temperature, about 30-something degrees. So when the wind takes it away, it leaves me feeling a bit colder. Second, this new air also needs to be heated. Right? Your body will use energy to heat up this air that's coming in. After all, the air it already warmed up is gone. So the more wind there is, the more you keep exchanging the air that you're spending energy to heat up. It might be a bit confusing, but let's suppose you want to cool down a hot potato. Running water will cool the potato faster than placing it in still water. It will work much better under the faucet because the water is flowing, since you can transfer heat much faster. But there's a third factor that might be the coolest of all, which is when the wind blows, it speeds up the evaporation of your sweat. It makes the moisture on your skin evaporate faster, and evaporation takes away heat, making your skin feel colder. Let's do a practical experiment so you can see.
Augusto thought he was just going to watch the video behind the camera, but now I need him to help me record. How are you doing?
I'm good.
Augusto is a physics teacher. He came to visit us here this week. I'm taking advantage of it since my arm's injured. Let's go. The idea is that blowing air will expel alcohol, lowering the temperature, which will be visible on the thermal camera. Do you think it's going to work?
Let's test it. Let's go.
You can record now. Look at my arm, look how cool it is. Let's record a little so we can understand how it works. Watch my hand. When I squeeze it and release, the spot I squeezed is left hot and marked. Now I'm going to take my hand, I'm going to pour isopropyl alcohol here on my hand and look.
It appeared.
Did it appear? Let's see on the table.
Yeah, it's much better on the table.
The table.
Yeah, I chilled it.
Ah, it's proven that it works. There it is. One of the answers to that question is that evaporation steals the heat. Are you right? Physically speaking.
Correct, that's right.
Let's record again, but this time there's a little dot there that marks the highest point, the hottest thing on the screen, and another one that marks the coldest thing. And there's also one in the center of the screen, marking the temperature of the center of the screen of what's being filmed right there in the middle. Here, for example, what's the temperature more or less?
20 degrees Celsius.
It's 20 degrees. Let's play. It must have already gotten dark. At the same time, it already turned blue. Because the temperature drops, because the alcohol is evaporating. As soon as I'm pouring it, it's already evaporating.
And then
It's showing 14,
14.
13.9.
He's already getting dizzy.
How much was it?
It was 13, a little over 13.
Man, it dropped almost 7 degrees. It's really cold. So, our theory is proven. Next video, I'll answer why we get dizzy when we blow a lot, okay?
If there are no words in Portuguese with K, Y, and W, then why are they in our alphabet? In the past, these letters weren't officially in our alphabet, but we've always used them. On the typewriter, for example, they weren't removed from the typewriter when the letters weren't in our alphabet, because there were a lot of foreign words that use K, W, and Y, and we keep using those words the same way they're written outside Brazil. If you take out the W, for example, how would you write Washington? How would you write Wilson? You'd need to adapt these words to Portuguese. Using a U, for example, would look odd. And there are a lot of words that we have adapted to Portuguese. Yes, shampoo, for example. In Portuguese, we must use an X, but some words still retain other letters, even though they're part of our language. For example, windfall and windsurf. In English, there's no E at the end, but in Portuguese, it's windsurf, though the W remains at the start. Today, these three letters are now officially part of our alphabet, VOF. But they will mainly appear in words that came from abroad, like windsurf, or in acronyms that use words that came from abroad. For example, kilowatt, kilowatt, or in proper names, such as people's or place names like Washington and Wellington. Hello, people of Manuel do Mundo. Hello to Lee. Leo Jacob. Do refrigerator magnets have infinite strength or do they wear out? We have a wrong idea that a magnet has some kind of energy inside it, that it's magical in some way. But I'm going to show you something very similar to a magnet, and you'll see that there's no way a magnet can wear out like that. There's no way for the magnet to lose its energy. Look at this tennis ball. What happens if I drop the ball? It's attracted to the ground, right? It goes to the ground. And if I pick up the ball and drop it again, it goes to the ground once again. And if I drop it again, it goes to the ground again. And if I drop it one more time, it goes again. And you know what happens if I drop it one more time? It falls to the ground once again. There is an attraction here between the ball and planet Earth. Both want to stay together. And this, in our minds, is already part of our daily lives. And we know this doesn't end. Whenever I drop the ball, it will be attracted to planet Earth, and planet Earth will attract the ball. This is much like what happens with a magnet. On planet Earth, we know there's no magic battery there, no energy that makes things accumulate. Actually, we can use gravity to store energy when we lift something up. When I let go, I convert that energy into kinetic energy. Magnets also let us do a lot with energy. If you put magnets inside a generator and move a coil of wires near the magnet, you can generate electrical energy, Eek. But it doesn't come from nowhere. The force you use is converted into electrical energy. Short. The magnetism of the magnet works in a way very similar to gravity. There's no magic energy there. The magnet may weaken. If you heat it up, for example, it's not because its battery got weak. It's because you misaligned the tiny magnets inside it. I think making a video on how a magnet works would be worthwhile. Don't you agree? What is chalk used on blackboards made of? I really like doing this segment because the question seems super simple, but it's not. Theoretically, chalk is made of chalk. That's right, chalk is the name of a rock that's mainly made of calcium carbonate, which is a white powder. So if you look up chalk mines or chalk mountains, anything like that, you'll probably find pictures of mountains made of white powder. That's how chalk used to be made in the past, but nowadays chalk isn't made from chalk anymore. Chalk is made from gypsum. If you check the box, it says gypsum or gypsite. I'm not sure how to pronounce it, but dehydrated gypsum, which in other words is plaster. Composition, calcium carbonate and pigments. I bought this chalk here to try it out, and in fact it's a chalk made of chalk. I'll tell you guys that I've already gotten a box of chalk that was made of something else entirely. In practice, what you really need is just a powder that's been compacted, and if you can get it into the shape of a little rock that crumbles when you write on the board, right? A rock that leaves a mark when you write on the board, just like what happens with pencil lead. But researching other brands of Brazilian chalks, wait, is the plural of giz really gises? Yes, the plural of giz is gizes. So looking at other brands of chalk, I saw that most of them are made of plaster, which, by the way, is related to chalk, okay? Instead of being a calcium carbonate, it's a calcium sulfate. Looking at the formula, calcium carbonate. 3, and calcium sulfate also contains calcium, but is bonded to SO4. Why don't you post much about your personal life? Well, I do post a little about my personal life when it has something to do with Manual do Mundo. So if I'm building a shelf at my house, if an animal shows up there and then I want to talk about that animal or about having a plant, sometimes my personal life relates to what we discuss on Manual do Mundo. But when it doesn't, like when I'm playing with my daughters or traveling with Mari for fun, it's different. I don't think that's part of what we're talking about on Manual do Mundo. Also, if I post about my personal life and it becomes part of my job, I'm working all the time. I'll be spending my weekends thinking about what I'm going to post. How can I make that moment I'm living more Instagrammable or something like that? And then I'll stop truly living things just to post on social media. And that's not what I want. I think it's important for us to have a separation between what is our daily work and what is our life there, right? That you can disconnect from everything and enjoy a little. Since I have 2 daughters, I want our time together, what they grow up to be as a family, that we really enjoy it, that this isn't part of work. Do comets have gravity? Anything that has mass has gravity. So, when I showed the tennis ball falling, it's not just planet Earth that's attracting the ball. The ball is also attracting planet Earth because it has gravity. You who's behind the screen watching this video have gravity. But of course, that's a really weak thing, right? The ball doesn't stick to me because it's being attracted by my gravity. The planet Earth will exert a gravitational attraction. It has much more gravity than my body, so the ball goes to the ground and barely even feels my body. And I think that's where your question is. And that's why I think this show here is different. Because I could stop here and say, oh, a comet has gravity. Yes, it has mass, it has gravity. No, no. I think your question goes in a much cooler direction, which is, okay, the comet has gravity, but does that gravity influence anything? For example, if a spacecraft lands on the comet, can you feel that gravity? When the comet passes close to planet Earth, does it disturb planet Earth? Does it pull on planet Earth in any way? To start with, then let's think about the size of a comet. Halley's comet, for example, which is the most famous of all, is 11 kilometers in diameter. Just so you have an idea, planet Earth is 12,576 kilometers in diameter. Diameter is if you stick a needle through, right? A skewer straight through. That means if we took planet Earth and Halley's comet, put them both on a giant floor and compared their height, planet Earth would be 1,000 times taller. Our moon, which isn't even that big, has a diameter of 3,476 kilometers. So it's also much bigger than the comet, which means in practice that the gravity of the comet does exist, but it's very tiny. Based on my research, comet gravity is 10,000 to 100,000 times weaker than Earth's, depending on comet size. That means that as a guy who weighs 85 kilos, if I were on the comet and put a scale under me, that scale would show about 0.8 grams. Or on a slightly bigger comet, 8 grams. I would practically not feel that gravity at all. Any little push I gave with my foot, I would go flying away forever and say goodbye to that comet. Its gravity wouldn't be enough to hold me. And that brings a challenge when we need to explore a comet. right? We've already landed a spacecraft and a probe on a comet. The problem is that even a small bump can make the probe bounce and fly away. So gravity doesn't pull hard enough to stabilize the landing of these objects, you know. So it's much harder, it's complicated to land on an object like that because the attraction is just so tiny. Armageddon lands on an asteroid, right? Yeah. In practice, it would be very difficult. If someone took one step, they'd just fly away. What happened in the movie isn't possible. If we see the past when we look at the universe, how are we going to find life outside of Earth? We think that light is super fast, but that's not exactly true. It travels at about 300,000 kilometers per second. Here on Earth, it's fine. Everything you see is pretty much instant, right? You're not seeing things with a delay. Time moves so quickly that when I look, my hand is right there in that instant. But looking at the moon feels different. The light from the moon takes 1 second to get here. So when I look at the moon, I'm seeing the moon with a 1 second delay. I'm seeing the moon as it was a second ago. When I look at the sun is much farther away. Its light takes 8 minutes to get here. So I'm seeing a sun from 8 minutes ago. So that means that in space, this fast speed of light isn't really that fast. When we observe distant stars, we may be seeing them as they were 1,000,000 years ago, because the light it emitted took 1,000,000 years to reach you. But here's the thing, light also includes, for example, radio frequency, right? Radio communications. That means, for example, when Mars is far from planet Earth, right? Because Mars and Earth are both orbiting the sun. Sometimes Earth is very far from Mars, like when Mars is on the sun's opposite side. And then at that moment, a message from Mars to Earth takes 20 minutes to arrive because that message travels by radio. If you reply, it takes 20 minutes to arrive. So if I say hi, that message also takes 20 minutes. The person replies hi, another 20 minutes to reach me. So the response comes 40 minutes later. But we're talking about the solar system. The closest star to us is 4 light years away. If an extraterrestrial lives there, a message would take 4 years to reach him and another 4 years for his reply to return. So, for example, I say hi. When the message reaches a 10-year-old extraterrestrial, he replies, but by the time his response returns, he's already 14. But most stars are at a much greater distance. So this communication becomes practically unfeasible if we receive and decipher an extraterrestrial radio signal now. It's a message sent centuries, millennia, or even millions of years ago. That civilization may no longer exist. But there's a detail, the life we're looking for outside Earth doesn't have to be intelligent life. For example, when the robots are digging on Mars looking for life, it doesn't mean they're going to find a little figure that talks and walks. They'll probably find some microscopic being that was once alive. Maybe we'll find evidence that life once existed there, but not actual life. So when we explore, especially the solar system, we're not looking for intelligent life, we're not looking for other civilizations. They're very simple forms of life because we already know there's nothing very complex around us here, since we've already explored the solar system quite a bit. Outside, it's much harder to know, but even if they exist, it's going to be really complicated for us to communicate with those folks. In the game, stop. If we play and get the letter I, and I write colorless, does it count as a color? Look at this letter I at the beginning. It means it doesn't have. Tinko. So infinite, for example, is something that has no end. Useless is something that is not useful. Unfair is something that is not fair. So colorless is something that has no color. If you're asking for a color and you put something that has no color, I don't think colorless counts. If there are so many satellites, why don't we see them from down here? And why doesn't it block the sun? Breno, you can see them. Yes, I had the same question as you. Many satellites pass overhead. And now Starlink, which is that company by Elon Musk that wants to provide internet to the whole world, is launching constellations of satellites. It's like an endless mountain of satellites orbiting Earth, never stopping. So, last year, we went to Sitio Curaçao to record some Iberê episodes there. It's always here in Tatuí. It's close to Sao Paulo, but it's a place that already has very little light. So at night, you can see the sky very clearly. You see a lot more stars than you do here in Sao Paulo. Coincidentally, there's an astronomer named Luis Moreno who works there. So The first thing I asked him, I said, Luis, I've never seen a satellite passing in the sky. Don't you see them here from time to time? He said, there are several passing by now. Look at the sky. Yeah. When I looked up, I started to notice that there were about 3 stars that were moving. And it's different from an airplane. You can tell by the speed it's moving. It's faster than an airplane. And it doesn't blink either. Usually an airplane blinks. And anyway, just by looking, you can already tell it's not an airplane. It's something different. He said he often sees satellites. I recorded the satellite passing by because my first thought was to capture it no matter what. This is the video you're watching now. There was a satellite passing in the sky at that moment. So the answer to your first question is yes, you can see satellites. They don't emit light. They reflect it. Like the moon, sunlight hits the satellite and then reaches us, so you see a shine move across the sky. When Sputnik was launched, which is the first satellite in history, it was launched by the Soviet Union in the 1950s. The whole world could see the reflection of the rocket that launched this satellite, which was moving across the sky. And that was one of the things that scared people, right? Because you looked at the sky and saw that the Russians had managed to do it. The Russians at that time, right? The Soviets launched something and their enemies thought if they can send this over us, they could launch an atomic bomb at us. Historically, seeing satellites has been common for a long time. Your second question is also very good. When a satellite like that crosses the sun, it doesn't cast a shadow on Earth because it's too small. And astronomical transit occurs when one object passes in front of another, such as Mercury or Venus passing in front of the sun. But they're so far from planet Earth and not that big, so they won't cause an eclipse. There's a photo of Mercury's transit. We call this passage Mercury's transit. You can see it's a very tiny little dot passing in front of the sun. And when a satellite passes by, for example, the International Space Station or the Hubble satellite, we could also see it from Earth with a telescope. But once again, it's like an ant. It's a tiny thing passing in front of the sun. And the coolest thing is that there are some websites where if you enter your location, they can calculate when you would be able to see the transit of the International Space Station or the Hubble, for example. So you can look through a telescope. Look, the website is this one, transitfinder.com. One of my dreams here at Manual do Mundo is for us to be able to record one of these transits. But there's a detail, it's very fast. It's not like a lunar eclipse, right? When the moon passes in front of the sun and we see the eclipse, it takes a long time. You can stop, have a snack, have some coffee while watching it happen. When the International Space Station passes in front, it's very close to planet Earth and very fast. Just so you have an idea, it goes around planet Earth 15 times in one day. When it crosses the sun, it only lasts about a second, so you must capture that moment. Recording and photographing it is tough, but maybe we'll manage someday. Let's move to our final question. The one you thought you'd clicked for, but really it wasn't the question that made you click. If you watch Manual do Mundo, you know Iberê Answers features lots of cool questions. You'll clear up doubts you didn't know you had and finish the video having learned a lot. Iberê, what are rare earths? After all, what are they used for? The rare earths are 17 metals, 17 chemical elements that are here on the periodic table. They are the ones from the lanthanide series. Ow, my arm! I had shoulder surgery 15 days ago. I had a cartilage here that had ruptured, it had torn. Ashto. Also, a bone was rubbing against another because the cartilage between them had worn out. So, in my surgery, they had to stitch up that cartilage that came loose and also shave the bone a bit so that the cartilage between the bones could recover there. Even though my shoulder looks fine, it isn't working properly, I can't lift weight. So, for me to lift this finger from my knee, I can't do it with my right hand anymore. I also can't straighten my arm. So in the video so far, I haven't done so. I can't properly point at the periodic table. Please forgive me. Going back to rare earths, they are all the ones here in the lanthanide series, which starts with lanthanum and goes on. They're all pretty weird names, okay? We're not really used to this, like praseodymium, cerium, dysprosium. These things we don't usually hear about in our daily lives. And besides these, scandium and yttrium are also usually included in the rare earth series, which are these two right here. So sometimes you'll see the name rare earth elements, which stands for rare earth elements, because they are actual chemical elements from the periodic table. They are all metals and they are all related. That means they behave in a similar way chemically, more or less like sodium and potassium. And what's important about these chemical elements is that they are widely used in cutting-edge technology.
I'll give a few examples here. Cerium is used in LED lamps, europium in screens and monitors, lanthanum in solar panels. Cerium, dysprosium, yttrium, and lanthanum are used in vehicles, while europium, cerium, dysprosium, yttrium, and lanthanum are used in aircraft.
There are many other examples, but one we often use on Manual do Mundo and find very useful is neodymium. They're used to make supermagnets. You might wonder, what are supermagnets for? We use it for experiments on Manual do Mundo, but what is its real-life purpose? For example, it's the magnet inside a hard drive that guides the read-write head. It's a high-performance motor like those in electric cars. You need very powerful magnets, neodymium magnets. In a magnetic resonance imaging machine, you also need a strong magnet, neodymium. For high-quality headphones or speakers, neodymium magnet. In the end, then these are metals we use to make expensive things we're using more and more, especially now that everything is electric. Can you imagine why the United States is negotiating there with Ukraine? They want Ukraine's rare earths because the world is going to need more and more rare earths. And there are several things we can't build without them. But then why are they called rare earths? The name is old. Earth refers to their occurrence as oxides. So for example, you won't find pure neodymium like a big bar of neodymium underground. You'll find neodymium oxide, a kind of neodymium rust, mixed in with a bunch of other things. And rare doesn't mean they're uncommon chemical elements are found everywhere you dig, but only in small amounts. You won't find large pieces of neodymium even though many ores contain it. No, they're scattered. That's why they're considered rare, because it's hard to find a mine where they're concentrated. And even if you find them, it's hard to extract them to separate these chemical elements. Often, for example, they bring radioactive material and other unwanted items. But what about Brazil? Is this available in Brazil, or is it only Ukraine that has rare earths? Not only do we have it in Brazil, but the second largest reserve of rare earths is here. The first country is China, and the second is Brazil. But we hardly produce any rare earths. We import everything from China. Brazil only extracts and processes a tiny bit here. A cool fact is that monazite, which contains rare earths, is a mineral commonly found in Brazil. Santo, there's even a beach sand called monazitic sand due to its monazite content. That's the sand in these little tubes. In fact, monazitic sand contains radioactive elements like uranium and thorium. If we put this in a Geiger counter, theoretically, it will beep. This is Manual do Mundo, right? We do have a Geiger counter, but I can't get it out of here. Let's go. Every time we hear a beep like this, it means there's radiation coming here. Okay, so you can hear it going beep, 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 because there's radiation in the environment when I get close to the monazite sand. Let's see. The counter here goes all the way to the maximum. That means, yes, there's radiation here. It's not dangerous radiation, it's just a little, but the counter is clearly detecting it. Let's be honest, you won't see this on every channel. Remember to like the video. Okay. If you liked our periodic table, it's the periodic table that appears in the Great Book of Chemistry from Manual do Mundo and in the Great Book of Science. Okay, they're two really cool books. The science one is mainly for beginners, especially elementary and early middle school students. And the Great Book of Chemistry covers pretty much all the chemistry you learn in school up to the end of high school.